Let's have problem 70. Use the method of joints to determine the force in each member of the truss shown below. State whether each member is in tension or compression. So first, let's compute the reactions. So call this RF. This is a roller support, so there's no horizontal component of reaction. At E, we have 1,800 newtons to the left. 900 plus 900 is 1,800. So EY is downward, and EY is equal to RF. So summation moment about F equals 0, counterclockwise positive. So we have EY times 3 equals 900 times 2.25 plus 900 times 4.5. Solving for EY, which is equal to R sub F, it is equal to 2025 newtons. First, we look at joint B. This is case 1. There are only two meeting forces, therefore each force is 0. So FAB is 0 and FBD is 0. We then proceed to joint A. So these are the forces. Take note that FAB is 0, so we don't consider it. The slope of FAD is 3 horizontal, 2.25 vertical, which can be reduced to 4 horizontal to 3 vertical. So the hypotenuse is 5. Same is true here for member CF. So at joint A, summation forces x equals 0 to solve directly FAD. So FAD times 4 over 5, the horizontal component of FAD, plus 900 equals 0. Therefore, FAD is negative 1,125 newtons, and negative sign means the member is in compression. So FAD is 1,125 newtons compression. Then summation forces y equals 0 at A. FAC is downward, so negative FAC. Then negative of negative, because FAD is downward, so negative, and its magnitude is negative also. 1,125 times vertical component is negative 1,125 times 3 over 5 equals 0. So FAC is positive 675 newtons, or FAC is 675 newtons tension. We then proceed to joint D. Because at joint D, there are only two unknown members here. So we transmit the value of FAD, which is negative 1125. FBD is 0. FCD unknown, then FDF unknown. So to solve for FCD, we sum up forces x equals 0. Or to solve for FDF rather, we sum up forces y equals 0. So negative 1125 times 3 over 5, the vertical component of negative 1125, equals FDE. So FDE is negative, FDF is negative 675. Sorry, this is FDF. So, or FDF is 675 newtons compression. Then summation forces x equals 0. So negative FCD leftward, then negative of negative 1125 times 4 over 5 equals 0. Or negative 125 times 4 over 5 minus FCD equals 0. So FCD is positive 900 newtons, or FCD is 900 newtons tension. Then we proceed to joint C. Then let's transmit the computed values. There are only two unknowns, FCE and FCF. So the forces are FAC is 675, so that's tension. FCD is 900, we have just computed. FCF unknown and FCE unknown. So to solve for FCF directly, summation forces X at C equals 0. So FCF times 4 over 5 plus 900 equals 0. So FCF is negative 2,250 newtons, or FCF is 2,250 newtons compression. Then summation forces Y equals 0 at C. So 675 equals FCE plus FCF, which is negative 2,250 times 3 over 5. So 675 equals FCE plus negative 2,250 times 3 over 5. The vertical component of FCF is its magnitude, which is negative 2,250 times 3 over 5. Solving for FCE, FCE is 2025 newtons, or 2025 newtons tension. Then we proceed to joint E. Then let's transmit the values, computed values. So FCE is 2,250. This is FEF. So summation forces X at E equals 0. So rightward force FEF equals 1,800. So that means FEF is 1,800 tension. Then we check if joint E is in equilibrium vertically. Summation forces Y equals 2,250 minus EY, which is also 2,250, minus EY, which is 2025. FC is 2025 equals 0. So summation versus Y equals 0. 2025 minus 2025 equals 0. So that means it is balanced vertically. Then we proceed to joint F. Let's check if F is in equilibrium. Let's transmit the values, computed values. So summation forces X at joint F. So summation forces X equals 0. So negative 1,800. Then minus negative 2,250 times 4 over 5. Then it is 0. So that means minus negative 2,250 times 4 over 5. So it is 0. So that means F is in equilibrium horizontally. Then summation forces Y is negative 675 plus RF, which is 2025. Then plus 2025 plus negative 2250 times 3 over 5, and the result is 0. So that means it is also balanced vertically. So since the last joint is in equilibrium, that means that all our answers are correct. So that's it for this problem. So here is the solution to problem 71. Use the method of joints to determine the force in each member of the truss shown below. State whether each member is in tension or compression. So this is the given figure. First, let's compute for the reactions. Call this RG. This is a roller support, so there's only one reaction, vertical reaction. Then at F, we have 15 kips to the left because the external force is to the right, and Fy is anticipated to be downward. So summation of moment about F equals 0, counterclockwise positive, so we have Rg times 20 equals 15 times 16 plus 40 times 15. So again, Rg times 20 equals 15 kips times 16 plus 40 times 15. So R sub G is equal to 42 kips upward. So therefore, Fy, summation moment about G equals 0, counterclockwise positive, so Fy times 20 plus 40 times 5 equals 15 times 16. So that means Fy is 2 kips downward. So it checks 2 kips downward plus 40 kips downward is 42 kips downward equals Rg, which is 42 kips upward. Then we proceed to joint G. So the slope of FEG is 5 horizontal, 10 vertical. Therefore, it is reduced to 1 horizontal, 2 vertical, square root of 5 the hypotenuse. So summation forces X at G equals 0. Since there's no other horizontal force at G, we conclude that FEG is 0. So FEG times 1 over square root of 5, negative FEG times 1 over square root of 5 equals 0. So FEG is 0. Then summation forces Y. So we note that positive sign means tension while negative sign means compression, because we always assume that the member force is in tension. So at G, summation forces Y equals 0. So we have FCG plus RG, which is 42, equals 0. So that means FCG is negative 42 kips. Meaning of negative 42 kips, FCG is 42 kips compression. So it is already mentioned here. If it is positive, it is a tension member. We then proceed to joint F. Take note that DF has the same slope as EG. So we have FDF and FBF. Same slope. So summation forces X equals 0 at F. So we have FDF times 1 over square root of 5 equals 15 kips. Rightward component equals leftward component. So FDF is equal to 33.54 kips. It is positive, so it is understood tension. Summation forces Y at F equals 0. So we have FBF plus 33.54 times 2 over square root of 5 equals 2 kips. Times 2 over square root of 5 equals 2 kips. So FBF is negative 28 kips. So it is compression. We then proceed to joint B. Then we name the forces at joint B, FAB, FBD, and we have FBF, which is negative 28 kips. The angle that AB makes with horizontal, so let's use angle instead of slope, is arctan of 4 over 10, and that is 21.801 degrees. And the angle that FBD makes with horizontal is arctan of 6 over 5, because this is 5 and this is 6, so that's 50.194 degrees. So first equation, summation forces X equals 0 at B. So we have FAB cosine of 21.801 plus FBD cosine of 50.194 equals negative 15. Because it is opposite, plus 15 equals 0, so transpose 15 to the right, so negative 15. Call that equation 1. Summation forces Y equals 0 at B. So FAB sine of 21.801 minus FBD sine of 50.194 equals negative 28, or equals downward force. Equation 2. Solving these two equations simultaneously will give us the following values. FAB is negative 30.96, or FAB is in compression, and FBD is equal to 21.48 kips, so it is in tension. Then we proceed to joint C. Take note that C and B have, or the members have the same angles with horizontal. So we name the forces as FAC, FCE, and FCG, which is equal to negative 42. It's now transmitted here. So summation forces X equals 0. Leftward forces positive. So remember the angles are the same. So FAC, we treat leftward forces positive. So FAC cosine of 21.801 degrees plus FCE cosine of 50.194 degrees equals 0. So call that equation 3. Then summation forces y equals 0 at C. FAC sine of 21.801 minus FCE sine of 50.194 equals negative 42. So call that equation 4. Solving equations 3 and 4 simultaneously will give us the following values. FAC is negative 28.27 kips, so it is compression. 28.27 kips compression, FAC. And FCE is positive 41.00 kips, so it is in tension. Then we proceed to joint D. Let's transmit the computed values of the forces and the unknown members. So FAD unknown, FBD is 21.48 kips. Then FDF is 33.54 kips. And the angle that FAD makes with horizontal is arctan of 10 over 5. This is 5 feet. Arctan of 10 over 5 is 63.45 degrees. So to solve for FAD directly, we sum up forces y at D equals 0. So FAD sine of 63.435 plus 21.48 sine of 50.194 then equals 33.54 times 2 over square root of 5, the vertical component of 33.54. So from there we can solve FAD, which is equal to 15.09 kips. So it is positive, so it is tension. Then summation forces X at D equals 0. So we have FDE plus FAD, which is 15.09 cosine of 63.45 degrees equals 21.48 cosine of 50.194 plus 33.54 times 1 over square root of 5, the horizontal component of 33.54. So from there we can solve FDE equal to positive 22 kips. So FDE is also in tension. Then we proceed to joint E. We transmit the computed values, and the only unknown force here is FAE. So to solve for FAE, summation forces y equals 0. Then let's check E if it is in equilibrium horizontally on the next slide. So at E, summation forces y equals 0. FAE, same angle here, sine of 63.45 plus 41 sine of 50.194 equals 40 kips because this is 0. So FAE can now be computed. It is equal to 9.507 kips tension. So that's it for this part. We will check joint E if it is in equilibrium horizontally on the next slide. So let's check joint E if it is in equilibrium horizontally. So summation forces X equals 41 cosine of 50.194 minus 22 minus FAE, which is 9.507 cosine of 63.45. So computing these values, it is almost 0. Therefore, joint E is in equilibrium horizontally. And finally, we have a remaining joint A here, which we have not yet investigated. So to validate our answers for the member forces, A should be in equilibrium. So let's recall the values of the members at joint A. FAB was negative 30.96, FAD was 15.09, FAC was negative 28.27, and FAE is 9.507 kips. So let's transmit it. Let's check joint A. So these are the values. And therefore, summation forces X equals negative 28.27 cosine of 21.821 plus 9.507 cosine of 63.435 minus 15.09 cosine of 63.45 minus negative 30.96 cosine of 21.801. So computing these values, it is almost zero. So that means joint A is in equilibrium horizontally. So the last part would be to check if it is in equilibrium vertically. So if it is in equilibrium vertically, then that means all our answers for the member forces are correct. So summation forces Y, downward positive this time because all these components are downward. So negative 28.27 sine of 21.821 plus 9.507 sine of 63.435 plus 15.09 sine of 63.435 plus negative 30.96 sine of 21.801 degrees. And using your the calculator, you evaluate this. It is almost zero also. Therefore, all our answers are correct because the last joint is in equilibrium. So that's it for this problem. I hope that you were able to follow the solution. And for the last problem, problem 72, use the method of joints to determine the force in each member of the truss shown below. State whether each member is in tension or compression. So here we go. This is the given problem. So by looking at the truss is geometrically symmetrical. The truss is symmetrical. The loadings are also symmetrical. Therefore, we only analyze the left portion of the truss because the forces on the other right corresponding right members have the same member forces expected because of symmetry and because of the loadings that are also symmetrically applied. So the total load is 300 plus 600 plus 600 plus 600 plus 300. That's 2,400. Therefore, the vertical reaction here is half of 2,400, so 1,200 pounds. This is also 1,200 pounds. Then the horizontal component of reaction at H is 0 by summing up forces horizontal. So we begin with analyzing joint A. Then we name the member as FAB and FAC. The angle that FAB makes with the horizontal is arctan of 6 over 8, so it is 36.870 degrees. Summation forces Y equals 0 to solve for FAB directly at joint A. So we have FAB times sine of 36.87 plus 1,200 equals 300. Solving for FAB is negative. FAB is also equal to FH by symmetry, and it is equal to negative 1,500 pounds, or FAB and FH are in compression. So 1,500 pounds compression. So that's the answer. You may just write negative 1,500 pounds. It is understood. They are understood compression. Summation forces X equals 0 at A. So we have FAC plus negative 1,500 cosine of 36.870 equals 0. So FAC is positive, which is equal to FGH also, 1,200 pounds. We then proceed to C. This belongs to case 2 for determining zero force members. So AC and CE are collinear, so they are equal. And therefore, FBC is automatic 0. So FBC equals FFG by symmetry, because this is also unloaded, 0. Since FCE is equal to FAC and FCE is equal to FEG, therefore FCE equals FEG equals FAC, which is 1,200. So FCE equals FEG equals 1,200 pounds, also in tension. We then proceed to joint B. Then we name and transmit the computed values. So remember, this is 0, this is negative 1,500. Then we have FBD and FBE. The angle that FBD makes with horizontal is arctan of 2 and 1/3, because this is 2 feet and 4 inches. 4 divided by 12 is 1/3. So 2 and 1/3, or arctan of 7/3 divided by 8. And the angle is 16.260 degrees. Again, arctan of 2 and 1/3, or arctan of 7/3 divided by 8 is 16.260. While the angle that BE makes with the horizontal is arctan of 6/8, so it is still 36.87 degrees. So we cannot solve directly FBD and FBE, so we set up two equilibrium equations. Summation forces X first at B equals 0. So FBD cosine of 16.26 degrees plus FBE cosine of 36.87 degrees equals negative 1,500 cosine of 36.87 degrees. So simplifying, FBD cosine of 16.26 degrees plus FBE cosine of 36.87 degrees equals negative 1,200. Call that equation 1. Then summation forces Y equals 0 at B. So we have FBD sine of 16.26 minus FBE sine of 36.87 equals 600 plus negative 1,500 sine of 36.87, or equals negative 1,500. The vertical component of negative 1,500 is negative 1,500 sine of 36.87, then plus 600. This is downward to right. So simplifying, FBD sine of 16.26 degrees minus FBE sine of 36.87 degrees equals negative 300. Let's call this equation 2. So solving equations 1 and 2 simultaneously will give us the following results. FBD, which is symmetrically equal to FDF, is negative 1,200 or 1,200 pounds compression, while FBE, which is expected equal to FEF, is equal to negative 60 pounds, so also compression. Then we proceed to joint D. At joint D, we don't need to check it horizontally. It is balanced because FDF equals FBD. So we just compute FDE at joint D. So these are the values. So summation forces Y equals 0 downward as positive. So FDE plus negative 1,200 times sine of 16.26 times 2, because there are 2 of them, plus 600 equals 0. So FDE plus 2 times negative 1,200 sine of 16.26 plus 600 equals 0. So solving for FDE, FDE is 72.00 pounds, so it is tension. Finally, we check joint E. Check equilibrium of joint E. We transmit the computed values. So FBE, which is F equal to FEF, negative 60 pounds. FDE is 72 pounds. Then FCE, 1,200, 1,200. So obviously, summation forces X is 0 at E. We just check summation forces Y if it is 0. So at joint E, summation forces X is obviously 0 because the values are equal to the right and to the left. Then we just check vertically. Summation forces Y equals 72 plus 2 times negative 60 sine of 36.87. So that's why we multiply it by 2 because there are two negative 60 upward. Then computing the values, it is almost 0. So that means joint E is in equilibrium horizontally and vertically. So that validates our answers to be correct. So that's it for this problem. I hope that if you're going to solve truss problems by method of joints, you're able also to analyze it well. So remember that when you apply method of joints, make sure that at a joint there are only two unknown members or unknown forces so that you can apply method of joints.